Hello there, this is Mr. Sutton, and we're going to start focusing on some non-parallelogram quadrilaterals. In this one, we're looking at the trapezoid and using properties of trapezoids, both regular and isosceles, to determine relationships between their parts. So, just to take another quick look at a quadrilateral land with my little Venn diagram here, we just got done dealing with parallelograms. Trapezoids, as you can see, are completely outside the parallelogram family. So we're going to take a look at those now. The first property we'll look at for trapezoids, and also the definition of a trapezoid, is that it's a quadrilateral with exactly one pair of parallel sides. This is not saying at least one pair, it's saying exactly one pair. So here's your trapezoid. Here are your parallel sides, A, B, and D, C. And just to look at some of the anatomy now, the bases of a trapezoid, which we'll refer to sometimes, those are the two parallel sides. So DC and AB in this one. And then this is in contrast to the legs of a trapezoid, which are the non-parallel sides over here, AD and BC. The base angles are the two angles that are on the same parallel side. So you've got a pair up here with D and C, and down here with A and B. The mid-segment is a segment connecting the two midpoints of the two legs. So here's your mid-segment, and because it is connecting the midpoints, that means that ED and EA are the same, and also that FC and FB. For our second property, we're going to do a little think ahead here. Take a look back at that last diagram on page 4, slide 4, and see if you can figure out the relationship between angles A and D. Think you've got it? So this leads to our second property. The same leg angles of a trapezoid are going to be supplementary. So if angle D is x, then that means angle A is going to be 180 minus x. And this comes from the fact that you just have two parallel lines with a transversal. A and D, those are consecutive interior angles. Same thing with C and B. So if this is y, this will be 180 minus y. Now this is a little bit different than a rectangle where we had x and 180 minus x over there, and over here we had like x and 180 minus x, and we had opposite angles being congruent. This is totally different from a trapezoid. The angles over here on this leg have no bearing on the angles over here on this other leg. And finally now, our third property of regular trapezoids, the mid-segment property. This says that the mid-segment of a trapezoid is parallel to both bases, and it's 1/2 the sum of the bases. In other words, you average the bases together, and you can have the mid-segment. So that last property on mid-segments is especially helpful in a problem like this, where they want you to find the length of the mid-segment. So again, mid-segment is just half the sum of the two bases. So half of 64 plus 82. So that's going to be, let's see here, 73 altogether. Half of 146, 73. There we go. Here's another trapezoid example. Pause the video and see how many of these missing letters, X, Y, and Z, you can find. All right, let's see how you did. We're going to start with X. Now, since X is part of the mid-segment, we're going to use a mid-segment setup. We can say that 2x minus 1 is equal to 1/2 of 10 plus 44, which is to say equal to, let's see, this is half of 54, so 27. Adding 1 and dividing by 2, we're going to end up with 14 for x. Let's go ahead and find y and z now. For angle y, that's going to be supplementary with this other base angle up here, 110. So that's going to end up being 180 minus 110, which gives us 70 degrees. And then finally, for angle z, we can't assume that angle z is the exact same as this other base angle, 110 degrees. It could be the case, but it doesn't have to be that way. But what we do know about angle z is that it is supplementary with 30 degrees down here. So 180 minus 30 gives us our angle of 150 degrees. At this point, we're going to talk about some properties of isosceles trapezoids. In an isosceles trapezoid, one property is that the legs are congruent, just like an isosceles triangle. So here's an isosceles trapezoid, which we're going to mark the legs congruent in. Now, since the legs are congruent in an isosceles trapezoid, that means the base angles are also congruent. So these two angles down here should be the same, and so should these two up here. Finally, one last property of isosceles trapezoids is that the diagonals will also be congruent. So here's how I'm going to represent this. This isn't saying that the diagonals bisect each other, but whatever these two lengths are, when you add them together, you're going to get the same thing as when you add these other two lengths together. Pause the video for a moment, and using what you just learned, see if you can figure out the missing angles in this diagram below. All right, let's see how it went. The easiest one on here to get is going to be angle H, because this is an isosceles trapezoid. We know that because of the two congruent sides, and we know it's a trapezoid because of the parallel sides here. So that means that angle H and angle J are going to be the same. So base angles congruent, that means H is also going to be 110 degrees. Now how about F and G? Well, we don't know either one of these, but if we find one of these angles, we get the other one for free, again, because base angles are congruent in isosceles trapezoids. So we know in all trapezoids that the non-base consecutive angles, the same side, the same leg angles here, are going to be supplementary. So we know that angle F, for example, has to be 180 minus 110, or 70. And we know that angle G, which is the other base angle relationship with angle F, G is also then going to have to be 70. So that's it for trapezoids. Until next time, this is Mr. Sutton signing off.